We are going to discuss about different concepts of acids and bases. Acids and bases. So here we are going to see the different definitions for acids and bases. Now the first concept is the classical concept for acids and bases. So the first we have the classical concept. This you have learned in your lower classes about the acids and bases. Now, according to classical concept, and this classical concept, the acids and bases are classified on the properties possessed by them. So, the acid is defined as a substance whose aqueous solution possesses the following properties. First property, acids conducts electricity. Second, it turns blue litmus red. Third, acids, they have a sour taste. And last property is they can react with active metals like zinc, magnesium, etc. to give hydrogen gas. So these are the properties that is exhibited by acids. Now let's see the properties of bases. Bases also they conduct electricity. Second is they turn red litmus blue. Third, they have a bitter taste. Next, they have a soapy touch. And their basic properties are destroyed on reaction with an acid. So this is the classical concept given for acids and bases. Now next we have the second concept for acids and bases, that is Arrhenius concept of acids and bases. So the second one is Arrhenius concept. Very important concept. Now, according to Arrhenius concept, what are acids and bases? Acids are substances that dissociates in water to give hydrogen ions, that is H plus ions. And bases are substances that produce OH minus ions in aqueous solution. So, according to Arrhenius concept, acid means substances which dissociate in aqueous solution to give H plus ions or hydrogen ions, and bases means substances that dissociate in aqueous solution to give OH minus or hydroxyl ions. Now, according to Arrhenius concept, the ionization of an acid in aqueous solution can be represented as, I am taking a general expression for acid, that is HX, aqueous solution. It will dissociate as H plus plus X minus. So if you look at this equation, you can see HX can be called as an acid because it dissociates in aqueous solution to give H plus ion or a proton. We can call this a proton. H plus can be called as a proton because there is no electron present in H plus. So you can call it as a proton. Now I am going to write this expression also as, or in another way I am going to write HX aqueous plus H2O liquid will give. Now from HX we know H plus ion, it dissociates as H plus plus X minus. Now this H plus formed will combine with H2O. H plus is the proton, and this proton formed is very reactive because it is unstable. So what it does is it forms a bond with the lone pair. We know there are two lone pairs on oxygen atom in the water molecule. So this H plus will form a bond with the H2O molecule, and what we get is we get H3O plus ion plus X minus ion, and we can call this H3O plus as hydronium ion. So hydronium ion, how is it formed? When H plus combined with H2O, we get hydronium ion. Okay, so we can write it as H plus ion or H3O plus ion. Both means the same, but we don't find H plus ion because H plus ion is unstable and very reactive. So always it combines with H2O and we get H3O plus. So even there is no wrong mistake in using H plus or H3O plus. You can use H plus or H3O plus. Both are correct. Okay, now let's see the dissociation of a base. So, acid means which substances which produce H plus ion in aqueous solution. Now, let's see the dissociation of a base molecule. General equation, general expression for a base MOH. Aqueous will dissociate to give M plus OH minus ion. Now, this OH minus, we already discussed that according to Arrhenius concept, bases are substances which dissociate in aqueous solution to give hydroxyl ion. This OH minus is our hydroxyl ion. So you can call this MOH as a base because it gives OH minus ions in aqueous solution. Now, what are the limitations of this Arrhenius concept? So next we are going to see the limitations. There are two important limitations for this Arrhenius concept of acids and bases. The first limitation is that this concept is applicable only to aqueous solution. And second limitation is, we know that ammonia does not contain OH group, hydroxyl group, but we know that ammonia is a base. So the explanation for this, that ammonia is a base, is not done with the help of Arrhenius concept of acids and bases. So these are the two limitations of Arrhenius concept of acids and bases. So this is Arrhenius concept. So what are acids and bases according to Arrhenius concept? Acids are substances which dissociate in aqueous solution to give H plus ion, and bases are substances which dissociate in aqueous solution to give OH minus ions. So comes the third concept for acids and bases. So let's see the third concept. Number 3 is Bronstead-Lowry concept of acids and bases. Now let's see what is the definition of acids and bases according to Bronstead-Lowry concept. Now, acid is a substance that is capable of donating a hydrogen ion, and bases are substances capable of accepting a hydrogen ion. Or we can say acids are proton donors and bases are proton acceptors. So according to Bronstead-Lowry concept, acids are proton donors. Proton means H plus, and bases are proton acceptors or H plus acceptors. Okay, so acid means a substance which is capable of donating a proton. They are acid. And substance which is capable of accepting a proton, they are bases. So let's see two examples to explain this concept. The first example is dissolution of ammonia in water. Example 1, dissolution of ammonia in water. Let's write the equation for the dissolution of ammonia in water. NH3 plus H2O liquid. Ammonia dissolving in water, you get the product as NH4 plus, it dissociates to give NH4 plus aqueous plus OH minus aqueous. Now, this is the dissolution of ammonia in water, and the products formed is ammonium ion and hydroxyl ion. Now, let's find out what is or who is the base and who is the acid according to Bronstead-Lowry concept. We know that in this equation the ammonia molecule has gained one H plus ion, means it's a proton acceptor, and this ammonia adds a proton and it changed into NH4 plus. So here ammonia adds proton. So we know that if a substance accepts proton acceptors, they are called bases. So in this case the base is ammonia. Now what did H2O do? H2O donated H plus ion, and it donated or loses H plus ion to ammonia, and that H plus is taken by ammonia and changed into NH4 plus. So H2O loses H plus and it changed into OH minus. So here H2O, it loses proton. So we know that proton donors, they are our acids. So here H2O is our acid. Okay, so according to Bronstead-Lowry concept, in this reaction ammonia is the base and water is the acid, because ammonia is the proton acceptor and water is the proton donor. Now the product formed is NH4 plus, and the name of NH4 plus is ammonium ion. This is ammonium ion, and this is ammonia. NH3 is ammonia, and OH minus is hydroxyl ion. So the product formed is NH4 plus and OH minus. So you can see in the forward reaction the ammonia acted as the base and H2O acted as our acid. Now let's see the backward reaction. In the backward reaction you can see NH4 plus will give H plus ion to OH minus, and NH4 plus will act as the acid. So in the backward reaction we have NH4 plus acting as acid because it's a proton donor and it changes to NH3, and OH minus will accept H plus from NH4 plus and OH minus will act as the base in the backward reaction. Okay, now you can call NH3 and H2O as Bronstead acid and Bronstead base. Now the NH4 plus and OH minus formed, they are called conjugate acid and conjugate base. Okay, so I am going to write the word before this acid, conjugate acid, and this is conjugate base. And you can see NH3 and NH4 plus, they are conjugate acid base pair. They are called conjugate acid base pair. Same way we can write H2O and OH minus. They are another conjugate acid base pair. So what do you mean by a conjugate acid base pair? An acid base pair that differ by one proton, they are called conjugate acid base pair. Now you can see NH3 and NH4 plus, they differ by one proton. Proton means H plus. NH3 and NH4 plus has one extra H plus ion. And look at H2O and OH minus, they also differ by one proton, H plus. H2O has one extra proton. So you can call that a conjugate acid base pair. So what do you mean by conjugate acid base pair? An acid base pair that differ by one proton is called a conjugate acid base pair. Or we can also say NH4 plus is the conjugate acid of the base ammonia, and NH3 is the conjugate base of the acid NH4 plus. In the backward reaction, you can see NH4 plus will be the acid and NH3 will be the conjugate base. So, you can say like this, in this reaction NH4 plus is the conjugate acid of base ammonia and NH3 is the conjugate base of the acid NH4 plus. Also, we can say OH minus is the conjugate base of the acid H2O and H2O is the conjugate acid of the base OH minus. Now, how will you identify this or how will you write the conjugate acid of a base and conjugate base of an acid? There is a technique for that. Conjugate acid has one extra proton and conjugate base has one less proton. So, I told you conjugate acid has one extra proton. Now, you look at this example, NH3 and NH4 plus, and I told NH4 plus is the conjugate acid of the base ammonia. So, NH4 plus is called the conjugate acid because it has one extra H plus ion. So, if you are asked to write the conjugate acid of NH3, you add one H plus, it becomes NH4 plus. So, that is the conjugate acid. And if you are asked to write the conjugate base of NH4 plus, you remove one H plus because conjugate base has one less proton. So, the conjugate base of NH4 plus will be NH3. Same way, H2O and OH minus. H2O, if you are asked to write the conjugate base of H2O, you remove one H plus, you get OH minus, which is the conjugate base. And if you are asked to write the conjugate acid of OH minus, add one H plus, it becomes H2O, which is the conjugate acid of OH minus. So, these things are very important. That is what you mean by conjugate acid base pair. How will you identify conjugate acid base pair? They differ by one H plus ion. And how will you write the conjugate acid of a base? Conjugate acid has one extra H plus and conjugate base means they have one less H plus ion. Okay, so this is our first example. Now, let's see the second example, and you can see in this reaction the H2O acted as an acid. H2O is an acid. Now, I am going to write the next example, that is number 2. Example 2. Example 2 is ionization of hydrochloric acid in water. So, I am going to write the equation HCl plus H2O in equilibrium, we get H3O plus Cl minus. Now, let's see in the forward reaction, which is the Bronstead acid, Bronstead base, conjugate acid and conjugate base. So, if you look at this reaction, you can see HCl, it loses H plus and it changed into Cl minus. So, I am going to write HCl loses H plus or proton. Now, this is a proton donor, which means HCl acts as an acid. So, this is a Bronstead acid, HCl. And what will be Cl minus? Cl minus will be the conjugate base of the acid HCl. So, Cl minus is the conjugate base. And you can see this HCl and Cl minus, they are conjugate acid base pair because HCl and Cl minus, they are conjugate acid base pair because they differ by one H plus. So, here Cl minus is the conjugate base of the acid HCl and HCl is the conjugate acid of the base Cl minus. Okay, now let's take about water. In water, one H plus is added. So, it adds proton H plus and it changes into H3O plus. So here you can see H2O adds H plus and changes to H3O plus. Now H2O will add means proton acceptor, which means here H2O will act as a Bronstead base and H3O plus will act as a conjugate acid. So here the next acid base pair, conjugate acid base pair is H2O and H3O plus, and you can say H2O and H3O plus, they are another conjugate acid base pair because they also differ by one proton, you can see. And here H2O is the conjugate base of acid H3O plus and H3O plus is the conjugate acid of the base H2O. Okay, and you can see the conjugate acid has one extra H plus and conjugate base has one less H plus ion. So this is another example. Now in this reaction you can see the water acts as a base, and in the previous example if you check you can see this water acts as an acid. So what does it show? It shows that the water is amphoteric in nature. Amphoteric means it can act as an acid as well as a base. When it acts as an acid, it reacted with a base, and when it acts as a base, it reacted with an acid. So this shows the amphoteric nature of water, these two reactions. Okay, so this is about our Bronstead-Lowry concept of acids and bases. So according to Bronstead-Lowry concept, acids are proton donors and bases are proton acceptors. And we have conjugate acid base pair, that is acid base pair that differ by one proton, and conjugate acid will have one extra proton and conjugate base will have one less proton. Now there is one more thing that is to be remembered, a very important note, that is strong acids will have weak conjugate base and vice versa. So strong acids, the conjugate base of a strong acid will be weak. For example, HCl, hydrochloric acid, is a strong acid and its conjugate base is what? HCl, 1 H plus less, means we have Cl minus as the conjugate base of HCl, and the Cl minus is a weak base. Okay, and vice versa, which means weak acids will have a strong conjugate base. That is our acetic acid is a weak acid, CH3COOH. Now the conjugate base of acetic acid, this is a weak acid. Conjugate base will be CH3COO minus, which is strong. So this is a very important point. Strong acid will have a weak conjugate base and weak acids will have a strong conjugate base. So this is our third concept of acids and bases. Now the fourth concept and the last one is Lewis concept of acids and bases. So number 4. Lewis acids and bases. Now what are Lewis acids? Lewis acids are species which accepts electron pair, and Lewis bases are species which donates electron pair, or we can write Lewis acids, they are electron pair. Now here we consider electron, not proton. Electron pair acceptors. Acids, Lewis acids are electron pair acceptors, and Lewis bases, they are electron pair donors. Now let's see examples for Lewis acid and Lewis base. Lewis acid example is BF3, boron trifluoride. You know that BF3. Then another example, AlCl3, aluminium chloride. Now you can see the central atom, boron and aluminium, they have only 6 electrons around them. The octet is incomplete. So they are electron pair acceptors, which means they can act as a Lewis acid. Now usually they accept electron from ammonia, because ammonia is an example for a Lewis base. Because ammonia, you know, there is a lone pair on nitrogen. So BF3 will accept that electron pair from ammonia. So here ammonia will act as a Lewis base and BF3 will act as a Lewis acid. Okay. Now there are more examples for Lewis acids. There is the cations like magnesium Mg2+, then CO, cobalt ion, all these are Lewis acids because they will accept electron pairs. And we have more examples for Lewis base. There is H2O. H2O has 2 lone pairs, so which can be donated, so it is a Lewis base. Same way we have OH minus. OH minus also has a lone pair on oxygen which can be donated, so they can act as a Lewis base. So Lewis acid means electron pair acceptors and Lewis bases means electron pair donors. Usually these Lewis bases will have a lone pair on the central atom. Okay, so these are the 4 important concepts of acids and bases. The classical concept, Arrhenius concept, third one is Bronstead concept, and last is Lewis concept of acids and bases. Now next, I have written few questions on the board. The first question is, what is a conjugate base for the following Bronstead acid? So I told you conjugate base will have 1 less proton. So HF, what is the conjugate base of HF? 1 less proton means H plus is removed. So the conjugate base is F minus. H2SO4, 1 H plus when removed it becomes HSO4 minus. HCO3 minus, 1 H plus is removed means CO3 2 minus. So these are the conjugate base of these acids. Now question number 2. Write the conjugate acid for the following Bronstead bases. So here you have to write the conjugate acid. Conjugate acid will have 1 extra H plus. So NH2 minus, the conjugate acid will be NH3. Add 1 H plus. NH3, add 1 H plus to NH3, it becomes NH4 plus. HCO minus, you add 1 H plus to this, it becomes HCOOH. That is our formic acid or methanoic acid. So these are the conjugate acid of the following bases. Now question number 3. For the following species, write the conjugate acid and conjugate base. So both you have to write, that is conjugate acid and conjugate base. So I am writing here 2 columns, conjugate acid, conjugate base. Now H2O, conjugate acid means 1 extra proton. And conjugate base means less proton. 1 less proton. So H2O, 1 extra proton when added, we get H3O plus. Now to H2O, when you remove 1 H plus, it becomes OH minus. Now HCO3 minus, add 1 H plus, it becomes H2CO3. Now remove 1 H plus, you get CO3 2 minus. Now HSO4 minus, the conjugate acid is add 1 H plus, it becomes H2SO4. Now conjugate base, remove 1 H plus, it becomes SO4 2 minus. The charge increases. Now NH3, the conjugate acid is add 1 H plus, it becomes NH4 plus. Remove 1 H plus, you get NH2 minus. When you remove 1 H plus from NH3, you get NH2 minus. Now the last question is question number 4. Classify into Lewis acids or Lewis bases. OH minus is a Lewis base because the lone pair on oxygen atom can be donated or they are electron pair donors. F minus is also a Lewis base because it can donate the electrons or lone pair of electrons. Now H plus means proton. It's a Lewis acid because it can gain electrons or accept electrons. Now BCl3 is a Lewis acid because it's an electron deficient species and can accept electrons or electron pair acceptors. So, Lewis concept, according to Lewis concept, acids are electron pair acceptors, bases are electron pair donors. So, with this we complete the concept, different concepts of acids and bases. Thank you.